And good morning, good afternoon, good evening, good day, wherever you are. This is another video on Math Lam Pre-Calculus. Welcome. So today we have three small topics, each one fairly short. So we should be able to cover that in our usual half hour. So the first topic, we're going to be relearning how to solve absolute value equations. Then we're going to take a quick look at solving inequalities. Those two are not unrelated. And neither is this one, isolating one single variable in a linear equation. So these are the three topics of the day. Without any further ado, let us begin. This brush is really not doing a good job. And this guenille non plus. Aïe aïe aïe. Aïe 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 aïe. Aïe aïe aïe. Oh, oy, oy, oy. All right, first topic, solving absolute value equations. All right, absolute value equations. Okay, the strategy is very simple. What is the active principle here? Active principle is actually fairly simple, really. This is the type of thing that we're going to be looking at. We're going to have the absolute value of x plus or minus a number. Doesn't really matter what we put there. And because we want to solve equalities, it's going to be equal to, say, a number, say, b. So how do we solve this? Well, we break this up into two different categories. Either x minus a is equal to plus b, so exactly as it appears on the right hand side here, or the same thing, x minus a, but this time equal to the negative of what happens on the right hand side. So we will expect two answers out of this. Good. Now, remember what the absolute value does, right? We all remember that if we take the absolute value of, say, a positive number 8, and by definition we get 8. But should we want the absolute value of minus 8, then the negative is actually gone, and we get 8. We all remember that, I'm pretty sure. Okay, so what about an example? What about an example? So solve, did have something ready here. 2 multiplied by the absolute value of x plus 1, and that is equal to 10. All right, so we're going to tackle this pretty much the way we have it explained over here. First thing I'd like to do is get rid of the 2 here by dividing both sides by 2. So absolute value of x plus 1 is going to be equal to what? What shall we do here? Bring the 2 over, divide by 2, 10 divided by 2, 5. And then I'm going to break this into 2 sub-problems. One with a positive 5, the other one with a negative 5. Facile! That is easy stuff. So x plus 1 is 5, and x plus 1 is negative 5. As you can see, these are super easy equations to solve. Isolate the x, 5 minus 1 is 4. And here, isolate the x, you get minus 5 minus 1, so that is minus 6. Quick check. We're not required in here to do it, but we can take a few seconds and do it just to convince you that the answers are correct. Check x is equal to 4. Check x is equal to 4. Always put it back in the original equation. So 2 times 4 plus 1, absolute value equals 10. All right, let's take a look at this. 4 plus 1 is 5. Absolute value of 5 is 5. And 2 times 5 is 10. Check. Why don't we take a quick look at x is equal to minus 6? What happens if I plug that back into here? Well, that's 2 times minus 6 plus 1. Is that equal to 10? Absolute value of what? What's minus 6 plus 1? That's minus 5. What's the absolute value of minus 5? Is 5. 2 times 5 is 10. Both work. So if you're going to package your answer, you could actually put it in a box right here, somewhere on this extremely small whiteboard, and you can say that x is equal to -6 and x is equal to 4. We can leave it like this. The two answers separated by a comma. That will actually do for notation. Ça va? This is not hard. So you know what? I'm going to do just one example of this and save the time for other things that are a little more, perhaps, not challenging, but less, easy to solve. All right. Have to fight with this every time now. This whiteboard is coming to the end of its natural life. It's time for us to get back to class. Oh, if the variance can just disappear, how happy would I be? Would you be happy too? Happy too. So B, let's take a look at inequalities. Inequalities. Of course, what we want to do with them is to solve them, right? Inequalities. So what we have here, two types. So type 1. Type 1 is the linear type. Remember linear means what? Who remembers what linear means when we talk about equations? Linear means x to the power of uno, right? X to the power of 1. So what we do when we have that, we pretty much simply isolate the x. We simply isolate the x, given that the equation we want to solve involves x, of course. Now, one thing to remember here, so remember that if you end up multiplying by -1 in order to get what x is, then this changes the sign, the inequality sign, from less to greater, from greater to less. And this changes the inequality. All right? So I'm sure that rings a bell, but it'll probably ring a louder bell if we do it in an example. Oh, I forgot to label my example 1. You can give it 2.5 stars if you're keeping track. I'm going to give it, this one, 2.5 stars as well. So, solve. I do have something ready here. 2x plus 1 greater than or equal to 3x minus 7. All right. So, I mean, imagine that this was an equal sign instead of a greater than or equal to. What would you do? You'd bring the x to the one side, the constants to the other side. It's exactly the same strategy. So let me do this. 2x minus 3x. So this guy went over there. Greater than or equal to, I'm going to break the 1. It's going to go over there. It's going to become -1. -7 minus 1. So that minus x is greater than or equal to -8. Now I want to isolate x here, right? So I will need to do that. I will need to multiply both sides by -1. But in doing so, remember the remark, this greater than or equal to changes for a less than or equal to. So -1 times -x is x, and -8 times -1 is 8. And we can actually leave this as our answer. So we can actually put it in several ways. We can actually say that x is less than or equal to 8. Some of you may have learned the line notation like this. So you have the real line here, you have 8 here, and say 0 there, and x less than or equal to 8 would actually mean we shade on the line this way all the way down, and we include the value 8. This is simpler, but this also describes the situation quite well. So that's the linear case. Like I said, fairly simple in the sense that if this were not an inequality sign, if it were an equal, we would solve it the same way. The only thing we have to keep in mind is here, if there's a minus and we need to change the minus to a plus, we got to change the inequality sign. Good. So let's take a look at type 2, which is the nonlinear case. And the nonlinear case will actually be the quadratic case. So, quadratic case, type 2, so quadratic. So what happens quadratic? Oh, remember, yeah, for sure. Quadratic, what does it mean? It means x to the power of 2. So we're going to have here an inequality that will involve an x squared. So the strategy is very similar to the one that we had for equality. Remember how we solved something x squared equal to something? What did we do? We made it equal to 0 and we tried to factor. So it's going to be the same approach here. Strategy, make it so that it is less than or greater than 0. So the 0 is the key here. We want to have the x's on one side and we want to have the zeros on the other. Okay, and then basically what do? We try to factor the side with the x's. Obviously, we can't really factor the side with the 0. The side with the x's. And finally, so 1, 2, 3. And finally, we determine the interval. I'm going to show you exactly what I mean by this on an example in one moment. Finally, determine the correct solution interval. Determine the interval solution. The solution will here be expressed in terms of a bunch of values trapped between this and that. Okay? So, allow me to look at this in terms of an example. This probably is a little more challenging. Let's give it 3 stars. So solve the following inequality. Have something here for you. So solve 2x squared plus 7x less than 4. All right. So notice x squared, second degree. So we're not going to solve this as a type 1. Type 1 is x to the 1. Type 2, different, x squared. So we're going to make this equal or less than, should I say, or greater than 0. So that means for us in this example to bring the 4 to the left side. So the first thing that I want to do, let me do it over here. The first thing that I want to do is say this is the same as 2x squared plus 7x. And what happens to the plus 4? It becomes minus 4, yeah. Less than 0. All right. So remember, if this were an equal sign, what would you do? What is it that we used to do in the past? We tried to factor this, and if we can't factor it, we use the quadratic formula. But let us see if we can actually end up factoring this relatively quickly, because now we are very good with this, aren't we? We've been practicing this. We've been doing tons of problems. So let's see if we can dispose of this relatively rapidly. The factoring of this could be, I'm going to do a little bit of trial and error here. So 2x squared for me means 2x here and x1. 4, that can be 1 times 4 or 2 times 2, but I'm going to go with 1 and 4. And if I put a plus here and a minus there, I will leave it to you to verify that indeed what I have here perfectly corresponds to what I have over there. So let's assume that we can go over this and understand one another that this is correct. Now what does that mean? This means that this times this is less than 0. So the product of two things is less than 0, meaning it's negative. So what does that mean really? How do we make sense out of this? If this is negative and this is positive, right? If the first bracket here ends up being positive, well, the second bracket ends up being negative, well, the product of these two would be negative, and that's what I want. I want to be less than 0. But of course, vice versa would work, right? This one being negative and this one being positive would also generate a negative number. So how can we solve this in a relatively simple way? The answer is actually like this. So what we're going to do, we're going to say 2x minus 1 equal to 0, and we're going to solve for x. Then we're going to say x plus 4 is equal to 0, and we're going to solve for x. All right? So both are easy. 2x minus 1 is equal to 0. Bring the 1 over. Divide by 2. This is 1/2. And this is minus 4. Now, these are the two key numbers that actually will divide the real line. What do I mean by this? I mean, here's the real line, which extends from positive infinity to negative infinity. I'm going to put minus 4 here. And I'm going to put 1/2 here. And you know what this is going to do, folks? It's going to create 3 intervals on the real line, from minus infinity to minus 4, then from minus 4 all the way down to 1/2, and another interval from 1/2 to infinity. What we want is to determine which of these intervals will eventually satisfy the original inequality. And to do that, some of you will remember, I hope you do, super easy. Why? Super easy. Pick a number in each of these intervals and actually determine if it actually works in the equation or not. For example, here, pick a number between negative infinity and minus 4. So something on the left of minus 4, anything will do. Perhaps we can pick minus 5 here? Yeah? Let's pick minus 5 and try to see what happens when we plug back in minus 5. So remember what we had here? We had 2x minus 1 times x plus 4. This was the factored form of our quadratic expression. Put minus 5 into there. So what do we got? We're going to get 2 times minus 5 minus 1 times minus 5 plus 4. What the hey is that? 2 times minus 5 is minus 10, minus 10 minus 1 is minus 11. Minus 5 plus 4 is minus 1. What happens if you multiply minus 11 with minus 1? You get plus 11. So you get a positive number. That's why I'm going to put here, on top of that interval where I picked the minus 5, I put a plus. Because any number in this interval from minus infinity to minus 4, any such numbers that I put into my inequality here will generate a plus. Now let's pick a number between minus 4 and 1/2. What say you? Pick a number. What could you pick between minus 4 and 1/2? 0? Sounds good. Let's put 0 in there. 2 times 0 minus 1, multiplying 0 plus 4. 2 times 0 is 0, 0 minus 1 is minus 1. 0 plus 4 is 4. Minus 1 times 4 is negative. So I'm going to put a negative sign here, meaning that if I pick any number in this interval, it'll always yield a negative number. And that is good for me, isn't it? Because that's what I want. I want this expression here, which in factored form equals to that. I want it to be less than 0, which means I want it to be negative. So just for the sake of the argument, I suspect that the next one is positive, but I'm going to check anyway. Please pick a number between 1/2 and infinity. Say 2. All right, say 2. We're going to do it over here. 2 times 2 minus 1 and 2 plus 4. That's 3. That's 6. The multiplication of 3 and 6 is 18. It is positive. So, since, once again, I wanted the product of these brackets to be less than 0, I wanted that to be negative. This means negative. Less than 0 means negative. I look at my intervals. Which of these correspond to a negative answer? Between minus 4 and 1/2. And that's that. That's the answer to the problem. So the answer comes as an interval. So final answer. Oh man, So answer, final answer, we're going to go from, what did we say? We said -4 to 1/2. Notice that I am putting brackets that are oriented outwards. That means I am not including -4 and I am not including 1/2. And why is that? Because it's a less than, not a less than or equal to. If it had been an equal to here or there, then I would actually have closed brackets because my final answers would include both ends, right? But in this case, it's a strictly less than, so I do not include this. Of course, I can also write an interval -4 to 1/2 and shade this. That's the same thing. But here, I'm going to have to put an open dot, and I'm going to have to put an open dot because I don't want my endpoints, -4 and 1/2, to be included in there. Once again, pourquoi? Because this is strictly less than and not less than or equal to. Again, if that was an equal, then I would close these brackets, I would have them included. D'accord? All right, so again, that's that. And we'll do more problems similar to this one in class. But since you're watching this video, you have an overview of what's coming. So that is a good thing because I'm going to go quickly over the topic in class. And if you've been exposed to it before, then it's all going to be better. One more topic. So C for today. Isolate. Ah, that's easy. Isolate a variable. Now, the reason we kind of re-insist on this in pre-cal, it's because it's directly related to a segment of Calculus 1 called implicit differentiation. And it's also related to another segment of Calculus 2 called logarithmic differentiation. So you will see that again. So I'm going to tailor my examples to what we actually find in Cal 1. This is why the variable that I am going to want to isolate is going to be y with a little apostrophe here. Some of you who took just a brief idea of calculus in high school know that this is actually called what? What do you call this apostrophe here in math? You don't call it y apostrophe, you call it y prime. Yes? This is known as y prime. Yeah. So y prime. This is how we call this expression in calculus. It actually also corresponds to one of the central idea in the whole field of differential calculus. Good. So strategy, let's talk strategy to do that, to isolate y prime. So step one, bring all terms that contain y prime, all terms that contain y prime on the same side of the equation. Now we're back to solving an equation here, right? We left inequalities behind in the previous sub-chapter. So first of all, bring all terms that contain y prime on the same side. 2, factor out the y prime. And finally, 3, isolate the y prime. Pretty simple strategy. We have actually done exactly that when we solved linear equations in the previous video. Actually, not even the previous one, the one before the previous one. So it's nothing really new. The notation is slightly different. Let's take a look at an example. So what that would be example 4, I guess, for today. I'm reluctant to give it more than 2.5 stars because this is really not difficult at all. So isolate y prime if I give you the following equation. What do I have here? 2xy prime plus 3y minus 4xy plus y prime minus 2 equal to 0. That looks a little intimidating, doesn't it? This type of expression. And yet it is something that actually comes straight out of a calculus example. It's not really difficult to isolate the y prime out of here if we follow the guidelines over there. Bring all terms that contain the y prime on the same side. You have a y prime. You have a y prime. So you too are going to be on the same side. Why don't we leave them, step one, why don't we leave those two on the same side? So 2xy prime plus yy prime equals 2. Well, by bringing these to the same side, it means by default that we have to bring the other terms to the other side. So minus 3y plus 4xy plus 2. This is what I get by transferring this guy, and that guy to the other side. And step one is completed. We have actually brought all the y primes to the same side. Step two, get the y prime out of there by factoring it out. This is simple factoring of the y prime. Very easy step, isn't it? Take out the y prime from 2xy prime, 2x plus y. Nothing new happens on the right side. Nothing changes here. Finally, we are there. Let's isolate the y prime by doing what? Well, we're going to isolate the y prime if this term is gone. Since this is a multiplication, the opposite of multiplication is the division, so I'm going to divide both sides by the bracket. 4xy plus 2 divided by 2x plus y. And although this looks extremely ugly, it is the right answer. Y prime is exactly this. And that's what we're looking for. Again, we'll do perhaps a couple more of these examples in class if we have time. But yeah, that pretty much completes the technical part of algebra in this course. We've covered really all the bases. What we're going to do next is take all of these skills that we have acquired recently, and we're going to see if we can solve a few word problems. I'm hearing you from here, word problems. We're going to have some strategy for word problems, and once we have the strategy that are well falling in place, all we got to do is apply the algebra that we have reviewed together over the last couple of weeks, and you're going to see that those word problems are really not that terribly difficult. All right, so that's it for today. I will see you in class. I wish you well. Have a good rest of the day. Talk to you soon.